Dear students, today I am going to explain about desirable properties of transactions. Already we have seen what is meant by transaction, what are the different types of transaction, interleaved and parallel transactions, and so on, and various states of transaction and various operations performed on transactions, etc. Now we are going to discuss about the desirable properties of transaction. The desirable properties of transactions are called acid properties. That is, A indicates atomicity, C for consistency, I for isolation, D for durability. Each and every transaction, they have to satisfy these properties. First one is atomicity. Atomicity means a transaction is an atomic unit of processing. That already we know. If it is either performed in its entirety or not performed at all. Any transaction will take that should be performed completely or nothing to be performed at all. That will be, this should be enforced by recovery protocol. This is the main property of the multi-user transaction processing. Then only the concurrency control is possible, and then if any failure occurs, the recovery is possible. If any transaction operation we are taking means that will be performed completely or nothing to be performed. This example many times we have seen. When we are transferring the amount, that amount should be debited from your sender account and it should be credited to your the receiver account. Otherwise, only one operation amount will be debited, not credited. That is not a complete transaction. So, it should be performed completely or not at all. This should be enforced by recovery protocol. The next property is AC, consistency preservation. That is very important one. Each and every state, every time, the database should be in a consistent state. That means it has to satisfy the constraints specified for the corresponding database at each and every state. Okay, that is important. When it is changing from one state to another state during the transaction, it has to satisfy the consistent, that is, it has to satisfy the constraint enforcement. So, application programmers and DBML constraint enforcement are responsible for this consistency maintenance. And the third one is isolation. Isolation means even though transactions are executing concurrently, they should appear to be executed in isolation. If we'll take any multi-user environment, sometimes the more than thousands of transactions will be executed concurrently, even though the each transaction is performing its operation independently. Okay, so that is why it was called as isolation. And this is the responsibility of the concurrency control protocol that is responsible for achieving this isolation property. The last one is durability or permanency. Okay, so once the transaction is committed, that means once that all the operations, what transaction we are performing, everything is over. The transaction is committed means the changes, whatever we have happened, that will be applied to the database. Once it is applied to the database, then and never be lost because of subsequent failure. That means that will be stored permanently in the database. Never it is going to be changed because of failure. Okay, never it is going to be changed means never it is going to be lost because of any failure occurs. Okay, this operation should be taken care by the recovery protocol. Okay, so these are all the four important properties of transactions, that is called as acid properties: atomicity, consistency, isolation, durability or permanency. So each and every property is one corresponding protocol is responsible. Either recovery protocol or concurrency control protocol is responsible. Whatever, especially in that multi-user environment, the each transaction should enforce these four properties. then only the transaction will be executed successfully with the correct output. Okay, so that's all about the properties of transactions. The next class we are going to discuss about that concurrency control will go. We'll see the different types of concurrency control technique used. Then before seeing the concurrency control techniques, now we are going to discuss about the different types of transactions. Okay, serializability and non serializability and so on. Okay, thank you.